Everyone, today we are going to look at hydrates. I'm going to show you how to do these problems and explain exactly what hydrates are. So hydrates are compounds with water molecules bound to them. Hydrates are often used as drying agents or desiccators because they absorb moisture. Silica gel packets may be found in seaweed and electronics. These absorb moisture, and we actually worked with a hydrate in a lab in this class before. Remember that white crystal chemical? That was calcium chloride, and after a while it got kind of moist. That was one of the first labs we did. That was a hydrate. Okay, so for hydrates, the name and the formula need to show how many water molecules there are, and we use the word hydrate with a prefix. So basically, we name the ionic compound, and then we add the prefix before the hydrate. So whatever number, we use the appropriate prefix. So calcium chloride, dihydrate, di is 2, so there's 2 water molecules here. Chromium nitrate, hexahydrate, hexa means 6, so there's 6 waters attached to this chemical. Make sure you review your prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. Chemicals that do not contain water in their structures are called anhydrous. Okay, so an means without, hydrous, without water. Okay, hydrates are easy to spot because their formulas show these water molecules. So here we have CoCl2 versus the hydrated form, which is CoCl2 times 6 H2Os, hexahydrate. Okay. So again, anhydrous means without water. All right, so to determine the hydrate formula, we just have to do some mole conversions, determine the moles of water and moles of anhydrous compound, and then you take moles of water divided by moles of anhydrous, and you're just solving for a number, basically figuring out what number goes in front of H2O here. Okay, so we're going to do a few practice problems so that you understand how to do these kinds of problems. Okay, first, what is the formula of this hydrate CuSO4 times blank H2O if the anhydrous mass of copper sulfate is 25.42 grams and the mass of water is 14.3 grams? So we're given the mass of your anhydrous here and the mass of water. We're going to convert those to moles. So we're going to follow these 4 steps, and eventually we'll get the formula. So let's go step by step. First, convert H2O to moles. So we have 14.3 grams of water, and I'm going to set up my little T table here. I'm going to convert it to moles, so 1 mole on top. The molar mass of water goes on the bottom. Notice I'm using all the decimals here. I'm not rounding off. The more decimals you use, the more accurate your answer is going to be. So I recommend not rounding when doing these problems. Okay, and we end up with 0.79 moles of water. So that's the first step. And then we also want to convert the mass of the anhydrous, and that's copper sulfate, into moles of copper sulfate. So again, I'm using all the numbers here, and the molar mass of copper sulfate is 159.62 grams CuSO4. So I'm going to divide those 2 numbers. Okay, so what we're doing here is we're dividing by the molar mass. The more decimals you use, the more accurate your answer. And that's our anhydrous. And then you want to divide these 2 numbers, moles of water over moles of anhydrous. So I'm going to just put a line here which represents me dividing those two. Okay, and I get about 5. Okay, so what do we do with that number? Now we can write our formula. Our formula is CuSO4 times 5 water. So that tells you how many water molecules there are in your formula, and this is the final answer. Okay, so again, I just followed these steps here. I converted water to moles, I converted my anhydrous to moles, and then lastly, I divided those two numbers, and then that allowed me to write the formula. Okay, so here they give you all the masses that you need. In the next problem, they don't give us all the numbers we need. It says a mass of 2.50 grams of hydrated copper sulfate is heated. After heating, 1.59 grams of copper sulfate remains. That's going to be our anhydrous compound. So we don't know how much water evaporated. So before we can do all the other steps, we have to figure out what are the mass of water that evaporated. Luckily, there's an easy way to do that. All you have to do is subtract the hydrated amount from the dry amount, and that'll tell you how much water evaporated. Okay, so if you see a problem like this, all you have to do is take the difference to figure out how much water evaporated. In this case, it's 0.91 grams of water that evaporated. Okay, so let's use that information, and we're going to follow the same steps. We want to convert this to moles. So again, we're going to divide by the molar mass of water. Again, the more decimals you use, the more accurate your answer is going to be. So 0.05 moles of water. And I also want moles of my anhydrous, so I'm going to take that 1.59 grams of copper sulfate that was left. And we actually figured out the molar mass of copper sulfate already earlier, if you recall, 159.62. And we get 0.01 moles of CuSO4. You divide these two numbers, and I can already tell that's going to be 5. And then using that 5, we can now plug it into the formula to get Cu4SO4. And again, the 5 just goes in front of your waters, and we end up with the correct formula here. Okay, so the only difference here is that we had to figure out how much water had evaporated before we can do the other steps. So just a summary, here are the steps that we did. We converted water to moles. After figuring out how many grams of water evaporated, we converted anhydrous to moles. We divided those two numbers to get the number that goes in front of water, and then we wrote the formula. All right, you have a few of these practice problems. Make sure you ask questions. For you honors kids, this will be on your